Thank you very much for having me. It's a pleasure to be here. Today I do want to talk about the paradigm of design, the way that we think and how that informs our design. So it's going to be a bit of a high-level conversation, but we're going to talk about how we ground it through practical application at our firm. So I work at B+H Architects. We're an international design firm. We're a subsidiary of Savannah Jurong, which is based out of Singapore. There's 16,000 of us. We're engineers, architects, builders, really trying to build the built environment, and we're embedding biomimicry into everything that we do. So I'm going to start by saying that biomimicry is quite simple. It's simply a mindset, or a paradigm, or a lens. So 20 years ago, I would have looked at this picture and said, you know, I see some trees, some bushes, I see a pathway, some roots. But all of a sudden, when you shift that, you make a subtle shift and recognize a biomimetic lens is, this picture is showing me ancient elders that have long lasted climate change. I can see towers that are moving fluids up hundreds of feet without electricity or any mechanical devices. These towers are making solar collectors using benign manufacturing. In this picture, carbon's not a problem. Carbon is an essential building block of everything that you see in this image. So those solar panels, those solar collectors, are using a subset of the periodic table of elements. Everything in this picture is pretty much 6 elements. And these solar collectors fall once a year into a circular economy. When I look at this picture, I see no waste. There's no unemployment. I'm seeing towers that are communicating with each other, sharing information and resources through their mycelial networks. I see resilience in the way that these trees create this canopy. There's one tree that's 800 feet above the rest of them. That canopy creates this natural dissipating layer so that the environmental perturbations can't come in and disrupt the understory. So what I'm saying is that when I look at this picture through a biomimetic lens, I see a model for how to design sustainably. I see ideas that could be replicated in our own built environments. They're more sustainable, they're often more efficient, and they're very more often more beautiful. So this lens is important because how we design is very much informed by how we think. And I'm not sure if we take time to stop and think about what are the key assumptions that are driving our design. And this is what I studied in my PhD. I got really interested in why humans became so different from the rest of the natural world. What made us so unique? In part, it's the assumptions. Our brains need to simplify their environments. It's hard for our brains to experience the complexity of the natural world, so we need to compartmentalize it. So some of the key assumptions that have driven our designs are, one, this belief that we are somehow separate from nature, that we're a species that stands outside of nature. Another assumption is that we can resist, predict, or control nature. Or that nature exists solely for human consumption. It's something to take from rather than something that could teach us. And you can see that in the way that we do design. We design for 100-year storm events. We design to resist nature. We design to fight nature. And there's nothing that I would say was wrong with that paradigm hundreds of years ago. It's made us very successful as a species. So I'm not saying that these are wrong ideas or assumptions. I'm just saying that they're outdated. Because what we're seeing today is that these assumptions are now being confronted by the natural world. They're being challenged. They're being challenged because we've built ourselves outside of nature so successfully that we've created this gradient. There's this glaring contrast between us and nature. And that's all based on these assumptions. We're separate from nature. We can control nature. We can use nature. But the greater the gradient, the more expensive it is to maintain that separation. Just think of how much energy you put into your lawns from weeds taking over, or monoculture crops from being taken over by diversity. I also know we're putting a lot of energy into this and that nature wants to abhor this gradient, because if we all left the cities, what would naturally happen? Nature would take over. So it's expensive to continue to use these assumptions. It's expensive to continue to fight nature. And this is why I think biomimicry is so valuable, because in a time where we're facing wicked problems, we need a new lens. Wicked problems, this is what they call them in resiliency literature, they're wicked because they have no precedent for how to solve them. We don't know how to solve climate change. So the thinking of the past is not going to solve the problems of today. We need a new lens, and this is the power of biomimicry. Biomimicry subtly shifts the way that we look at nature and design, seeing it not as something to take from, but something that could teach us. So So at B+H, we're playing with this very creatively, organically. We worked with the healthcare industry to see how could we pull light into a building, recognizing that light is a natural healer. Those beds that are closest to the windows quantifiably show that you heal faster. So how do you pull light in? And we looked at polar bears and the way that their fur is translucent, their skin is black, and it pulls light in and heat. And so we played with, fiber optic cables and what if we could, and fish eyes, what if we could pull more natural light deeper into the platform, into our buildings? We designed this iconic tower, which I know is not sustainable, but we played with biomimicry in a way of how could we inform its shape and its structure using biomimicry. So this is in a river delta. It's a private client. And river deltas are very dynamic. They flow. The sediment flows as much as the water. And so how do you build a foundation in such dynamic climates? We looked at mangroves as an inspiration in the way that they have these unique root structures. We also looked at, partnered with our sister companies, RBG and Atelier 10, to build a structure that was emulating dragonfly wings. So nature is very clever. It uses information before it uses material. It uses form before it creates mass and structure. So in this, we're able to pull on the Fibonacci sequence, to pull on that dragonfly wing to make a building that used considerably less materials, but maintain that structural integrity. So biomimicry is quite simple. It's just simply asking, first, what do you want your design to do? If you identify that function, that's when you can start to pull from nature, because nature's doing a lot of the same functions that we are doing. To give you a case study, before B+H with my company Frontiers, we designed a house in India, and the client wanted all aspects to be biomimetic. He wanted this to be a playground for biomimicry. And so you could see, we looked at the functions. What do we want this design to do? We want it to collect and store and recycle water. We wanted to grow food. We wanted to create forms, to create materials, to create structure. We wanted it to passively cool, self-cool. Nature does all of these things. And so when we take that function, what do we want our design to do? We can apply it at different levels. So form is the entry level to biomimicry. It's when you copy shapes in nature. Velcro, inspired by burrs, you can see that translation of the hooking mechanism of the burr coming up and being an inspiration for Velcro, one of the most successful adhesives of our time. This is sexy, the sexiest part of biomimicry, because you can see the translation. You can see the biology go to the design. So for this house, we looked to the local genius. We asked, how do you cool yourself? Elephant skin, a massive structure. We got inspired by the wrinkling and wondered, how does that contribute to passive cool? And we found that I'll preface by saying I'm not a biologist. I dropped out of biology because I hated it. But when we were studying the elephant from this engineering lens, it's like, well, those cracks are trapping moisture. So when it throws water over itself and then runs to the desert or the hot plains, that crack allows that moisture to evaporate at a slower rate. So it cools this massive structure over a longer period of time. And we thought, what if we took that metaphor and applied it to the house? So we built this rock wall facade and hooked it up to the rain harvesting system and trickled water over it so that on the south side, when the sun comes over, that water, that moisture can be evaporated at a slower rate. In those cracks, you get a little bit of protection. We looked at barrel cactus and the way that those ribbing structures creates this microclimate, passively cooling this thing in the desert. We looked at a bunch of other organisms for form-based biomimicry, but I want to give you a flavor of what this kind of thinking looks like. So form is the first level. Architects use it a lot. They often use it just for marketing. But when you start to understand that nature uses form for efficiency, that's when you can start to make a little bit more strategic sense. And this is where passive design, I think, is really embodying that. Learning how to leverage the free resources. But the next level is process. How does nature manufacture? Think of spider silk. Spider silk has a strength-to-weight ratio greater than anything we've ever made as humans, except the spider's making it at body temperature, body pressure, again, using a subset of the periodic table elements, using only the energy of the sun. And in fact, that spider will eat that silk, so it's fully biodegradable, fully recyclable. We want to learn from nature's processes to be more efficient. And again, we did Want to know how to passively cool this building? How does nature cool? This is one of the more famous examples. There's a shopping center in Zimbabwe that emulated termite mounds. Mick Pierce is the architect. But we learned from Mick, we learned from the termites to make this passive stacking effect so that we could passively cool. We could pull air, create circulation just through ventilation, through proper windows. We did the fluid dynamics to make sure we were doing the right thing. We also looked at prairie dogs and the way that they passively cool their mounds and their tunnels. And they have a unique kind of structure where they have these two entry points. And the windward side creates this little laminar flow, a little suction over this hump, so that when it goes to the other side, it creates this natural vacuum and just starts to suck the air out of the tunnel. And we use that as inspiration. We mapped out, the natural wind patterns of this site. This site, again, it was in Bangalore, India. We mapped out the urban flows, especially in the hot times, and then built forms and built structures to suck in that air, to suck in that fluid, and then put the walls in certain areas so that we can maximize the circulation within the building. And again, did some CFD modeling just to show that we're doing the right thing, to make sure we're on the right path, and to make sure there weren't barriers to this design. We also played with vernacular strategies. Anywhere you go, we've been trying to live in harmony with nature or try to deal with the complexity and the climate of our environments. So there's ideas we can pull on from the past. So in India, they have the Jolly system, which is a really brilliant kind of shading system, and we just paired it with a touch me not plant to make it more dynamic so that it's not homogeneous. Like, nature's very adaptive, very responsive. Nature uses information to adjust to its climate. We also wanted to capture and store water. In India, in this site, you have the monsoon seasons, these heavy rain events. But then you can have 100 days of drought. So how do you capture moisture, capture rain, and then maintain it over that period of time? In this case, we looked at the baobab tree, which has this really unique trunk, and then these clever little leaves. They're pretty small, there's not a lot of them, and they're very thick. So they're very efficient in how they evapotranspirate. And then we just use that as a bit of an inspiration for the kind of water, the water equipment that we're using. But we're able to design this site so it's fully self-sustaining. We have water recycling systems. We have on-site wastewater treatment using a wastewater garden. We're able to capture and store all the water on site and maintain it over 100 days of drought. So you got your form-based biomimicry. You got your process, copying nature and how it behaves. But I think the most important, and the one that I'm most intrigued by, is systems-level biomimicry, which is when you start to understand the principles, the design strategies in the natural world so that you can learn from them and harmonize with them. So instead of trying to fight nature, what if we played by her rules? What if we learned how to integrate with her? Because the thing about biomimicry and why I'm so committed to it is that there's no greater model of sustainability on this planet than nature. It's been around for 3.8 billion years, designing in the exact same context as us, often solving the same problems as us. Building materials, packaging, transportation, flight, food production, solar collection, energy movement. This is why I think biomimicry is so powerful, and what I want to kind of convey today is that passive design is a part of a bigger conversation. Nature is passive. You think of a tree and it's moving its limbs and its root structures to maximize its use of free energy. But if you also think about nature, things like additive manufacturing, circular economies, all these new trends that are coming up, passive and active design, 3D and 4D printing, nature's done all of that first. And so what I'm inspired by in biomimicry is it's also going to teach us what to do next. Right now, regenerative design is kind of the new buzzword. Nature is regenerative. So there's all these strategies that we can learn from nature, not just in passive design and not in regenerative design, circularity, but also it's going to invite us into this conversation with nature so that we can learn what to do next. And that's systems level biomimicry, is when we start to have that conversation and design with those principles. So in that same house, we partnered with our resident expert, Sebastian Ramirez, to design a permaculture strategy for this building so that it kind of turned into a forest. Because one of the things we're trying to do in all our designs is go beyond this idea of do less harm. Less harm implies that humans are a bad species, that we're just here to muck things up. But our philosophy is that our breath feeds the trees, our bodies feed the soil. Why can't our buildings feed their ecosystem? So in the permaculture strategy, it kind of gave us this lens like, okay, if we want to be better than do less harm, how do we quantify that? How do we measure whether we achieve that? And this is a strategy we use in all of our design processes, is we measure the ecological performance of that site. So it was a green field before we got there, and we measured how much CO2 is being sequestered, how much rain is being retained, how much noise is being reduced, how much oxygen is being produced. We measured all that before our design, and then measured it after our design. And in each case, we're able to show that the ecological performance of the site actually improved because we were there, giving us a sense of hope that this building is improving that system. It's enhancing that system. So the final thing I kind of want to talk about is, at that systems level, this is where we're playing a lot at my company, B+H, is in the planning. I'm quite convinced that the most effective tool for mitigating climate change is to let nature be. Nature's doing all of this free engineering for us. Why do we have to reinvent the wheel? How do we integrate then our built environments into those systems? And we developed something called the living story, which is a process of trying to map out what the land wants to do. You see, it's very expensive to fight nature. So if you can learn her story, learn her trajectory, learn how she can contribute to your design, there's lots of ecological systems that you can leverage. Well, then you can start to harmonize and design in flow with it. So an example, this is in Augusta Township in Eastern Ontario. We partnered with prefabricated, kind of off-grid design called Cabin, where they wanted to build a community around these homes. And we did that living story. We started to map out what's here, what are the ecological assets, where's there potential environmental and climate perturbations that could mess up our whole design. We designed it in a way to fit in with that, rather than try and fight it, rather than blindly bulldozing and trying to impose our own will, which we love to do as engineers. We love to bulldoze and start over and put some pipes in and make it predictable. But as we're seeing, it's not predictable as it was. Climate is unpredictable. And in this case, we found out that the already disturbed parts, the agricultural parts, are going to be the key areas to put these clusters. You'll also notice that the clusters have pretty small backyards because we recognize keeping the forest as a shared amenity is going to be more effective than building them all their own special backyards. And the clusters were inspired by this philosophy of villages. My friend John Watson told me that there's studies that show that over 150 people in your village, you start to lose that social connection. And the social connection is the key to resiliency. So I grew up in a small town of 2,000 people. I grew up on a farm. And I knew, my grandpa would tell me that when his barn burned down, or his brother's barn burned down, nobody called anyone. The whole town was there the next day to set it back up. And that's that social connection we're talking about. So we're trying to build this philosophy into our villages. So these clusters were designed in a way that they're also inspired by ants and the way that they communicate. I want to talk finally about, we mentioned the Indigenous people of this land. So living story and biomimicry does not exist without Indigenous knowledge. An elder who's a good friend of mine and married my wife and I 10 years ago, when I told her about biomimicry, she said, well, we've been doing biomimicry for thousands of years. And so in our living story, we try to engage the people who know that land better than we do. And we have a project in Kauai right now where we've done a year-long intensive engagement with the Indigenous people there, learning their own strategies and principles. We mapped out the ecological assets, so that's our site. It's a 10,000 square foot building. We got the coral reef on the right, the wetlands on the west. And we're leveraging that partnership to build in harmony with the land, and the Indigenous people are actually now leading that project. So I'll end by saying that the key to the biomimicry is that we need to shift the way that we think about design, because the longer one view is held beyond its time, the sharper and more extreme is the surprise, the perception of complexity, and the resulting adjustment, which is what we're seeing today. We've held on to a paradigm for too long. And I'll finish by saying that we've been given this masterpiece. My friend Gian Del Zotto said, we've been given a piece of art, a Van Gogh, a Monet, and we've been asked to add to it. And for the last couple hundred years, we've been scribbling on it indiscriminately, not learning the brushstrokes, not learning the subtleties of that masterpiece. Nature's already beautiful, and we've been asked to add to it. And so biomimicry invites us into this conversation with nature to learn those principles, learn the brushstrokes, so that we can contribute to that painting, we can contribute to the masterpiece. Thank you very much.